So we've talked about real numbers and the different sets within real numbers, but let's consider for a second if there are any non-real or unreal numbers. So consider our real numbers that we've been talking about for a second here. I want to ask this question. Are there more whole numbers than natural numbers? Well, if you look at the list, you go, well, sure, there's one more whole number than natural number because the whole numbers have 0 and the natural numbers don't. It's right there. So surely the whole numbers have more numbers than the natural numbers, or there's more whole numbers than natural. But how many natural numbers are there? Well, there's infinite. The natural numbers don't stop. When you get up to positive 1,150,002, well, the next number is positive 1,050,003. So they don't stop counting up and up and up. But clearly, there is one more whole number than natural numbers. Also, are there more integers than whole numbers? Well, yeah, in a way, right? Because integers have all these negative numbers plus all the whole numbers. So shouldn't there be more integers than whole numbers? But how do you have more than an infinite amount? Another question, are there as many irrational numbers as there are rational numbers? Because it seems like, with rational numbers, you can have 0.1 and 0.2, and I can put something right between there, 0.15. But I could also put 0.151 and 0.152. So it doesn't even seem like there's a way to quantify how many rational numbers or irrational numbers there are, because we can do the same thing with irrational numbers, just they won't terminate or be repeating. So what we're dancing around here is the infinite. What's at the end of a number line? Well, is infinity at the end of a number line, or negative infinity over on the other side? Are those numbers on the number line? Well, so basically what we're trying to get at is infinity a real number somewhere on the number line? Well, let's think about this. If infinity is at the end of the number line, what about infinity plus 1? Can you go past infinity? Well, that doesn't really make any sense, right? Because that would be like the new infinity. And so basically the short answer is that no, infinity is not a real number. It's not a number at all. It's a concept. Infinity is a concept to help us understand the non-endingness of something. But numbers as they are have to end. So infinity is not a real number. And how about the real numbers? Does that mean, so infinity is not a real number, does that mean that real numbers are all the numbers? Well, there's one number that we haven't really talked about, an important number, which we're not going to go into detail in this course, but that's the square root of -1. And you might have seen this before. The square root of -1 is what we call the imaginary number, which isn't a great name for it because the square root of -1 is not imaginary. I just wrote it down. It's right there. And it's actually a very valid mathematical number. Imaginary numbers are not real because you can't put them on the real number line, but they are real in that they're perfectly valid mathematical values. There's nothing less true about, or less numerical about the square root of -1 than the square root of 1. the difference is that this is a real number and this is a imaginary number. But in physics, it turns out that you cannot do high-level physics like quantum mechanics without imaginary numbers. Things like speed and distance and gravity, you can talk about all of those just in terms of real numbers. But one of the most famous equations in all of physics is called the Schrödinger equation. That's right down here at the bottom. And right there, smack in the middle of Schrödinger's equation, is the imaginary number I. And so it's just a fact of life that you cannot do high-level mathematics or physics without knowing about imaginary numbers. But we're not going to worry about them in this course.